are you sure about this?
I am positive about this. The George Washington University does some great research in honeybees.
Why bees? We're from the Air and Space Museum.
Well, a lot of great engineering designs have their basis in nature, and the aerospace industry is no different. In fact, the honeycomb found in hives is used a lot in the industry.
You just want me to get stung.
No, I don't want you to get stung at all.
Oh, you're concerned about me. That's nice.
No, actually, if you get stung, the bee dies.
So you're concerned about the honeybees.
Yep.
This
is STEM in 30.
Hi, I'm Marty.
And I'm Beth, and we are at the National Air and Space Museum's Stephen F. Udvar-Hazy Center in Chantilly, Virginia.
We are hoping that the episode today generates some buzz in your classroom because it's all about bees.
Now, as you walk through any air and space museum, you might not see the influence that bees have had.
Oh, but they have, and today we're going to look at that influence on some of these amazing artifacts.
Before we get started, we have to learn a little bit about bees. This is Dr. Holly Walker. She is from Smithsonian Gardens.
Holly, what are you guys up to?
Today we are going to be making mason bee houses.
Okay, but before we get started on mason bee houses, can you tell us, what are bees?
So bees are insects, and some of the basics of insects is that they have the 3 segments. Can you guys think of another feature that they might have that is part of being an insect or specifically being a bee?
Wings.
Wings, that's exactly it. So bees specifically belong to the order Hymenoptera, and Hymenoptera is one of the 4th largest orders of insects that we have in the world, which is really kind of fascinating. And specifically, Hymenoptera are known for having these membranous wings. That's actually what their name means, is to have these membranous wings.
What are membranous wings?
It's kind of like, you think of like cellophane or like glass, it's kind of this crinkly, almost translucent property to it. And the interesting thing is, for something that seems so incredibly delicate, it is structurally very strong. When you think about the fact that many insects, particularly bees, can fly thousands of miles over the course of days to avoid predators, to get through tough spots, and yet it all just looks like very fine glass that they're going on.
Do you guys have some questions for Holly?
I have a question. How long have humans been using bees?
We know that bees have been a part of human civilization for a long time, and that we've been using a lot of the different products that they have going back into Egypt, into early Greek civilizations. And one of the things that we know is that it's not just the honey that people were going after them for, even though honey is a wonderful source and it's a food and it's a sweetener, but they were also using things like beeswax because it's a really pliable kind of material. And they were also using things like royal jelly, which is something that the bees feed to their queen. They also have a bunch of other resources that we can use from them. We kind of domesticated them, so we made them so that they're easy for us to manage and take care of.
Local honey is so important. Why is that?
The reason that people always talk about getting local honey is because if you have allergies, like say to pollen, there are little bits of that are incorporated into the honey, and they believe that by having small doses of it, what you're actually doing is kind of inoculating your body a little bit to this pollen, and hopefully what it means is that you'll have less of an allergic reaction.
Any more questions?
How does the Smithsonian help bees?
So the Smithsonian has different ways in which it can actually help bees. Me specifically, I work for the Smithsonian Gardens, and we care a lot about habitat. And habitat includes things like planting the types of plants that are good for them, that provide good nutrients for them. A lot of times that includes plants that are native to the area, but also other types of flowering plants that produce a lot of pollen, a lot of nectar for them. So again, the easiest thing we can do is to plant gardens for them. But some of the other things we can do, which we'll get into in a little bit, is how to make homes for them or make space for them.
Well, when we look at all these airplanes, we can definitely see the influence of birds.
But bees are weird. How do they fly?
So bees actually have really interesting flight mechanisms. Most people, when they think about flight, they think of a very direct kind of flight where there's a muscle that pulls on the wings to make them be able to flap their wings. In insects, there's only two orders that really do that, and they're very primitive. One of them is dragonflies and one of them is mayflies. However, most other insects actually have something that's called indirect flight. And what this actually means is that they conserve energy by being able to use other muscles inside their body, and they actually flex parts of their bodies. So the way this works is they have their thorax, and they have their wings, and their wings are attached to the outsides of their bodies. But inside of them, they have different sets of muscles. They have some that run from top to bottom and some that run parallel through there. And what they do is they press their body this way or this way to move those muscles. And by doing that, that actually allows them to get both the lifting motion, but also to be able to angle their wings at different angles to get different types of speeds, or if they need to change their movement very quickly. It also allows them to create a general pattern that creates a vortex underneath the wings that lifts them up as they fly.
Wow, that is awesome.
When we walked up here, you were talking about mason bees. So what are mason bees? Why do they need houses? And how are they different from honeybees?
There's so much diversity in bees, and one of these groups is mason bees. Mason bees belong to this subgroup, which is the solitary bees. Unlike honeybees, which have a very social structure where there's a queen and she has workers, and there's a drone who's the male, and everybody has a role to play. When you talk about solitary bees, which includes mason bees, every female is her own queen and her own worker. She does all the work by herself, and she doesn't have a hive in which she works with. So it's very important for her to be able to have a home to put all of her eggs into, and know that after she dies, because she won't last to the next year to stay with them, that they'll be able to survive and reproduce on their own. A lot of solitary bees, but specifically mason bees, look for hollow stems or hollow structures, some that are already there, and they're able to actually lay their eggs inside these tubes. And each one is a little cell that they create. And what she'll do is she'll start with one end here, she'll lay her egg, and then she'll put a little bee bread, which is her little pollen and nectar piece of food, in there with the egg. She'll seal it up. Then she'll make another one, and another one, and another one, until she fills up the tube. And those will be her children for next year that will survive after she's left at the end of the season.
Y'all ready to make some mason bee houses?
Sure.
Yeah!
All right, come on up, guys.
So there's a lot of different types of materials that you can use to create mason bee houses, and the great thing is that they're really easy to come by. One of the easiest ones that you guys can get is the paper straws.
Holly, why do you use paper straws instead of plastic straws?
Sometimes they can become very brittle. Now you do have to sometimes be careful with paper straws. You want to make sure that they don't get too damp. You really don't necessarily have to have a container, but we definitely like to use and recycle cans like this. You can actually stuff these areas full of pine cones. This is cut bamboo that has been dried. This also creates more habitat for other types of insects and arthropods to go in there. You want to make sure that your pieces can be removed at the end of the season. You need to be able to change out the tubes every year, and then get your next one ready so that when the females come out in the spring, they're able to lay more eggs.
Well, we've got some really great houses here that we've made, but what are some other things that students and teachers can do to promote healthy bee populations?
I think the easiest thing that anybody can do is to plant plants and plant flowers. But just look and see what kinds of flowers that you see a lot of bees on, and plant more of those. And you will do so much for the bees in your area if you can just do this simple thing. And you don't need a lot of space. Bees really don't need a lot of room. So even if you just have a little pot on your balcony or your windowsill, plant some flowers for them.
As you can see, bees are really important.
And they help us out in ways you might not even realize.
If you've been inside an airplane, you've been essentially surrounded by a cocoon of honeycomb. The honeycomb is into the floors that you're standing on, into the walls, the ceilings, even in some cases the tray that comes in front of you, and sometimes the seats are made out of honeycomb. My name is Imad Atalla. I am the Director of Strategic Marketing for Hexcel. We make composite materials for uses in aerospace, airplanes, and the defense side, as well as in industrial applications. It's hard to miss on the logo. We make honeycomb. We also make carbon fiber. We make matrix products, which is known as pre-preg. We make reinforcements. anything that's a composite material that has benefits of weights and mechanical properties. Honeycomb is a very lightweight product that has very strong mechanical properties, so it tends to be very useful in applications where you need to lift things off the ground or they need to be light. I wish we can take a lot of credit for the honeycomb shape, but we actually stole it from bees. The hexagonal shape was found in nature essentially, and bees figured out that making their cocoons and their homes out of that shaped material presents the best, most effective way to make a strong structure with using the least amount of material. The different types of materials that are used for honeycomb, you can make it out of paper, out of fiberglass, and out of aluminum. Those are the three main types that we make. So essentially it starts with the material. We print adhesive lines at equal distances on the material, and then we take that printed roll and unroll it and stack the honeycomb where the adhesive lines are out of phase on top of each other. So you can imagine lines of honeycomb, and the second sheet would be where the previous adhesive line is in between the prior two lines, and that gets stacked to make a honeycomb block. Then what we do is we expand that block of honeycomb to the dimensions that is specified. Essentially what you're trying to do is you're trying to use the material in the most effective way. So by lining up the material perpendicular to the compression force and the resin that's on top of it, it makes it really strong in that dimension. And the fact that you have those hexagonal shapes and the material holding onto each other, it also has a good type of property in the shear direction. And the rest of it is air. So you get the benefits of being light as well as being strong for any applications that you need on an airplane.
We just saw a bee habitat that flew on the space shuttle.
And now we have a challenge for you all.
We have this big, heavy box. All right, set it down here. All right. Beth, what's our challenge?
Our challenge is that we want you to raise the box this high using a piece of paper.
Ooh, think it can be done?
Yes.
All right, let's try it. So Beth, hold that paper there. Let's pick this box up, see what happens. You ready? That didn't work very well. So how might we be able to make that paper a little bit stronger?
Roll it into a tube.
We could roll it into a tube. That's exactly right.
Do that.
Do you think this is going to work? You do?
Better than the first one.
All right.
All right, let's see. You ready?
Yeah.
You ready? Let's see. That didn't work so well. Holly, how do we make this work better?
Why don't we take some inspiration from the bees?
Ooh, you guys want to build something?
Yeah.
All right, come on
Come
in,
on
let's
up.
get to work.
Got a glue stick.
Hey guys, I have an idea. Why don't we try a honeycomb structure?
Holly, do you think bees would think we did a good job with this?
I don't think so. There's a problem with this structure. Even though it's easy for us to do it this way, bees actually wouldn't have all of these holes in between the individual cells. So the actual structure in a honeycomb is a hexagon shape. And that's actually really interesting because bees have figured out that that is the best use of the amount of material that they have. Bees only have so much wax that they can produce, so they need to make the best use of it possible. So the hexagon shape allows them to use the least amount of wax but have the most structural integrity so that it's the strongest it can be for that size.
Are y'all ready to see if this one's stronger than the individual tube?
Yes.
All right, let's see here. Big heavy box. All right, look at that. Good job. Now here at STEM in 30, we like to supersize things. To do that, we're gonna need a few more rolls. You guys did a great job making our giant honeycomb, but now we're gonna supersize it by having you stand on it. Do you think we can do it?
Yeah.
All right, let's give it a try.
All right.
Put that foot on my arm. Okay, go ahead and put a little pressure on. Put a little bit of weight on my arm. Boom! Boom! You can see how strong a honeycomb structure is, and that's why it's used throughout the aerospace industry, including in artifacts here in this museum. Check it out.
Scientists and engineers often look to the natural world to find inspiration. The honeycomb design is only one example of this, but an important one. Both strong and lightweight, honeycomb is an important element within the aerospace industry. Here at the National Air and Space Museum, there are plenty of artifacts that use the honeycomb. While our giant NASA full-scale wind tunnel fan is not made of honeycomb, the wind tunnel at the Langley Research Center in Hampton, Virginia relied on honeycomb to control wind turbulence while testing aircraft. The honeycomb design is lightweight but very strong, making it ideal for aircraft design. Using a honeycomb shape increases the strength of a part while keeping it lightweight. In modern aircraft, it is usually made of aluminum. As you walk through the museum, you can see many modern aircraft, but you may wonder where the honeycomb is. It can't be seen because it's found in between walls of the aircraft and through the wing. The Rattan Voyager is constructed almost entirely of lightweight composite honeycomb materials. During its record-setting flight, one of the wings was damaged. Inside the crack, you can see the honeycomb composite. Perhaps one of the most famous uses of honeycomb in aerospace in our collection is the Apollo 11 command module. The module, built in the 1960s, uses an aluminum honeycomb sandwich bonded between sheet aluminum alloy. The base of the module consisted of a heat shield made of brazed stainless steel honeycomb filled with an epoxy resin which served as an ablative material which burned away upon re-entry, keeping the astronauts safe inside. When visiting the command module, look closely and you can see the honeycomb pattern burned on the bottom of it. NASA still relies on honeycomb while designing its new spacecraft. If you look at the James Webb Space Telescope, you'll notice that its primary mirror is a giant honeycomb.
Well, we've made a little trip and now we're at the Smithsonian's National Museum of Natural History.
And we are joined by Dr. Sean Brady. You are an entomologist, correct?
Yes.
And you study bees?
I study bees.
These are all dead. Why do we study dead bees?
So we have a lot of live insects in the museum. There's a lot of them in the insect zoo. And also some of my colleagues do study live insects in their own labs. But all the insects I study are dead. And there's several reasons for that. First of all, when I want to look at an insect under a microscope, well, if it's alive, it doesn't do a very good job of staying put, staying under the microscope. And so we do a lot of very intensive studies of the morphology of bees to try to figure out what species they are and how they're using morphology. That's the physical structure of the bees, how the body parts are shaped. Bees have a lot of hairs, and so we study kind of how the hairs are distributed and how they help the bee to gather pollen.
What exactly is a bee?
Well, a bee is essentially a vegetarian wasp. Most wasps, they hunt prey, and they actually don't eat the prey themselves, but they lay their eggs either on the prey or sometimes even inside of the prey, and then the egg will hatch into a larva and then eat the prey from the inside. In fact, if you've ever seen the movie Alien, that was inspired by these kind of parasitic predatory wasps. Now, about 120 million years ago, for whatever reason, a lineage of wasps decided to kind of be more of a pacifist. And instead of hunting insects, it decided to feed off of plant pollen. The reason was probably because that's about when flowering plants evolved as well. And so they saw this new kind of food opportunity. And so they evolved to specialize in only eating pollen and nectar from the flowers.
How many species of bees are there?
Well, there are about 20,000 described species of bees, species that we know about. But there are many, many more thousands of species of bees waiting to be discovered, both out in nature and also in museum collections such as our own.
And you all have actually discovered new species of bees right here in your collection, right?
That's right. And my graduate student, Silas Bossert, was kind of nosing around this very drawer here. And he thought he saw a species of bee that's only known from 2 specimens in the whole world. And when he further explored it, he found a handful of these new bees in the collection, and he immediately knew that one was a different species of bee, a new species of bee, and he actually described it and named it after his girlfriend, which is flattering. If it was a cockroach, maybe not so flattering, but it's nice to have a bee named after you.
How many bees do you have in these drawers in this collection?
We probably have close to 1 million bee specimens, so I haven't had time to count them all. And if I were to count them all, we'd have new ones after I was done anyway. Our collections are an extremely valuable historical source for our knowledge of bees. Sometimes even we know we're collecting the same species of bee year after year after year, and we're preserving that information in the collection, because then researchers can use that information to basically go back in time. It's almost like a time machine.
When you think about Washington, D.C., you don't necessarily think about beehives.
Let's head over to the George Washington University to take a look at their hives and the research that they're doing on honeybees.
Hello, I'm Hartmut Birbel. I'm an assistant professor here at GW in the biology department, and I'm in charge of the apiary of hundreds and hundreds of thousands of honeybees. We have 16 hives. In the height of the summer, each one of those hives has as a minimum 20,000 bees, but we definitely had some hives that were 60,000 or more. In 2005, we learned more from beekeepers, small and large in the country, that we are losing our hives. So there was this thing called colony collapse disorder. So from one day to the next, bees disappeared. Pesticides can kill bees, and we all know that. So I thought, what if we are looking at such tiny amounts of pesticides that we hardly can detect, that basically do not kill the bees, and then see what kind of effect that has on the behavior of the bees.
We had a control group and then an experimental group where we would give the experimental group a sublethal dosage of glyphosate, and then we would put them in the maze.
This maze right here is what we used for our research this summer, and as you can see, it's a 5x5 maze. We teach the bees a specific path to follow, and in the path there are all right turns, and then at the end, once they've reached that said path and that goal chamber, they're rewarded. The way we train them is we have alternative chambers that they can go to. So we're giving them the option to go to separate chambers that are incorrect chambers. However, we still lead them. So that way we also know any chamber changes they have, any wrong turns that they have. And then at the end, we give them an hour break to let all the sugar water and the glyphosate be digested into the system. And then we check their retention to see if they remember the path.
What we're seeing is this overarching theme that observationally, the behavior is completely different. This in general would affect the agricultural chemicals that we should be using, because honeybees are a very big pollinator. They contribute about $20 billion that would be used for pollination, so trying to find different ways that we could support that community and support their species would be necessary.
The most important part is for you to get excited about some of the creepy, crawly stuff. So take a minute when you go home, to watch some insects, see whether you can discover a bee, whether you can possibly, see whether it's a bumblebee or honeybee. Maybe you can even discover some of those tiny bees that are also there. I know you're also going to make a difference by possibly telling your mom and dad to put some native plants in there, to put some wildflowers into your yard that bees are attracted to.
What we've done through our research is look at different green spaces and what plants they do prefer. And they end up preferring plants that have a small trumpet petal structure where they can stick their tongue or the proboscis in and suck up the nectar, which they bring back to their apiary.
Purple sage is a big one, hedge nettle, hydrangeas, coneflowers, echinacea.
Oh, yeah, coneflowers and echinaceas, yeah.
Build some artificial shelters for them where they can nest. That's also possible, and that's a lot of fun actually if you try that.
Today we've learned a whole lot about bees.
How can a middle school student be helpful?
There are a lot of ways to help bees. Be a builder. Build a bee habitat. You don't have to build an entire hive. Making a simple bee house will benefit bees in your yard, and this can be as simple as a tin can with paper straws. Build a bee bath. This is simply a glass or ceramic bowl with a few stone or marbles in it, and water is filled up to near the top of the stones. This allows the bees to land and drink. Be sure to change the water every day. Be a planter. Plant a pollinator garden. By planting varieties of flowers that bees like, you're helping them find an easy food source. And native plants are great. If you go to your local home and garden center, they can help you find which plants grow well in your area. Be nice. When you see a bee buzzing along, be nice to it. Don't swat or try to kill it. Bees don't want to sting you, and if you leave them alone, they will leave you alone. Be active. Look into local beekeeping associations and organizations. Most areas have groups that get together to talk about bees and to help each other learn about them. Join an association, attend a meeting, or just reach out to them for advice on how to be helpful. Remember, bees are important to the environment and to your neighborhood. Follow these simple steps to be helpful.
I know this stings, but we're out of time for today.
When we research these shows, we learn a lot of interesting things.
Like this thing? It's a bee sucker. You know what it does? Sucks bees right off of flowers. Put your mouth on there. Didn't know that before today.
We hope that you've learned a lot about bees and how you can help them.
Go ahead and give us a follow on social media and share with us how you are being helpful to bees.
We'd love to see your mason bee houses and any pollinator gardens you may develop.
And remember, the next time you eat honey, you're eating bee slobber.
Thanks for watching.
You're just you're just concerned about the
He has a great research program on honeybees. On honeybees.
Honeybees?
Honeybees.
Those sound delicious.
Little jelly beans.
Oh, behave. All right.
This is STEM and 30.
STEM and 30.
Solid, look at that.
There you go.